This video is brought to you by mywayteaching.com.
See in the figure, okay, a wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on top of the block, the floor heels steadily and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. Okay. What is the action of the block on the floor before and after floor heats? Take G is equal to 10 meter per second square. Identify the action reaction pairs in the problem. Here in the first, they have given a wooden block of mass 2 kg. So here wooden block of mass 2 kg, it is rest on a soft horizontal floor. When an iron cylinder, here you can consider iron cylinder of mass 25 kg is placed on top of the block, the floor heels steadily and the block and cylinder together go down with an acceleration of 0.1 meter per second square. So what is the action of this block on the floor before and after floor heels? And take G is equal to 10 meter per second square. Identify the action reaction pairs. So the block is at rest on the floor in the first case, isn't it? Its free body diagram shows two forces on the block. One is the normal reaction R and another one is the weight, isn't it? So the force of gravitational attraction by the earth is equal to 20 Newton and the normal force R of the floor on the block, by the first law, the net force on the block must be 0, isn't it? So this R and this the mg both are equal and opposite. So the net external force acting on this block is 0. So that is R is equal to 20 Newton. So using third law, the action of the block is equal to 20 Newton and directed vertically downwards. So the action of this block is what? It is equal to 20 Newton and it is directed downwards. And if you consider this second case, when an iron cylinder is placed on the block, so this system, that is the block plus cylinder, accelerates downwards with 0.1 meter per second square, isn't it? So the free body diagram shows that two forces on the system. The force of gravity due to the earth is 270 Newton and the normal force, that is R dash, by the floor. And the free body diagram of the system does not show internal forces between the block and cylinder. So applying the second law for this particular case, we can write 270 minus R dash. That is given by the mass 27 into 0.1. That is R dash is equal to 267.3 Newton. So R dash is 267.3 Newton. Okay. That 27 is what? That is nothing but mass, and 0.1 is acceleration. This is m and this is a. So according to second law, we get 270 minus R dash is equal to 267.3 Newton. So by the third law, the action of the system on the floor is equal to how much? 267.3 Newton. This is also acting vertically downwards, isn't it? Yes. Now the another part of the question, that is action reaction pairs. Okay. See, for the first case, the force of gravity 20 Newton on the block by the earth, say that is the action. The force of gravity on the earth by the block, that is reaction, which is equal to 20 Newton directed upwards, which is not shown in the figure. The force of gravity on the block by the earth, that is the action, and the force of gravity on the earth by that block is the reaction. Getting this point? Yes. And in the second case, the force of gravity on the system by the earth, so the force of gravity on the system by the earth, if you consider this as action, we can say the force of gravity on the earth by the system we can call this as reaction, which is equal to 270 Newton, which is directed upwards. And similarly, one more case here only, the force on the floor by the system, force on the floor by the system, we can consider it as action, and the force on the system by the floor is reaction. Isn't it? So the force on, in addition for B, the force on the block by the cylinder and the force on the cylinder by the block, they also constitute an action reaction pair. So not only this, we can consider one more action reaction pair, that is force on the block by cylinder. Okay, so this is also one of the action reaction pair. So the important thing to remember is that an action reaction pair consists of mutual forces which are always equal and opposite between two bodies. Two forces on the same body which happen to be equal and opposite can never constitute an action reaction pair. So the force of gravity on the mass m in A or B and the normal force on the mass m by the floor are not action reaction pairs because they are acting on the same body. These forces happen to be equal and opposite for A since mass is at rest. They are not so for case B as seen already. The weight of the system is 270 Newton while the normal force is 267.3 Newton. So the practice of drawing free body diagram is of great help in solving problems in mechanics. It allows you to clearly define your system and consider all the forces on the system due to objects that are not part of the system itself. So a number of exercises in this and subsequent chapters will help you to cultivate this practice. So, here action reaction pace we consider in the first case the force of gravity on the block by the earth is action and the force of gravity on the earth by the block is reaction and that is equal to 20 Newton. And in the second case we get three action reaction pace and the first one is force of gravity on the system by earth. If you consider that as action, then the force of gravity on the earth by system we can call it as reaction. And even the second case in that the force on the floor by the system, if you call that as action, then the force on the system by the floor we can call it as reaction. And the third case, that is a force on the block by cylinder, if you call it as an action, then the force on the cylinder by block we can call it as reaction, isn't it? So this action reaction pair it always consists of mutual forces which are always equal and opposite between two bodies, not in the same body. That is important thing that we should always remember. These are mutual forces which are equal and opposite between two bodies. So the free body diagram is also very helpful in solving the problems of mechanics. Okay, so this completes the laws of motion.